Welcome everybody to the, it says April in there. Good job with changing the slide, not so much. The May 2020 hybrid meeting. It's good to see you all. And all of you online, I already breezed through. I saw all of you. Some of you didn't have cameras on, which is cool. That's fine. But welcome everybody. As I said, those of you in the room, there's a bunch of stuff on the table over there. Help yourself. Take it home. Phil doesn't want it anymore. So I am the president.
Are you showing slide? Are you showing projecting something?
Yes.
Not seeing it.
John Zimmich is in the room. Trina's homesick. Matt Dunham is somewhere in the middle of Texas. Conrad, I haven't seen with my eyes tonight. He might be online. And Gunnar.
I'm here.
And Conrad is online. Very cool.
I am.
3/4 are here. 2/3, I guess. There's our faces. That's enough of that. So welcome new members. Any new members in the room tonight? Welcome. Thank you for coming. And the rest of you I have listed here. I've actually gone back because Steve Emmerich was so generous to give me a list of everybody that's joined since the 1st of April. So I just took them all. Whether you were on the previous slide, you're all here. And let me just tell you that welcome to the, I feel, the greatest club in America. Gee, you're rough crowd. So welcome. This is, in my opinion, the greatest club in America. We are definitely one of the larger, 660 members, I believe. There are so many opportunities for you to participate, for you to volunteer, for you to contribute, for you to help with the organization. I think whatever you want to do in this club to make it better, you certainly have the opportunity. And I certainly encourage you to check it out. Thank you, volunteers. I'm naming Steve Emmerich by name this month because he was instrumental in helping out with Vaults on the new website. They worked through a bunch of things associated with the membership and PayPal and all those things. And then I know that there's star parties at ELO. There has been Spring Astronomy Day. And then, my cohorts that live on the board with me, the members of the MAS board, incredible bunch. There's, we get along, we get the business done. And hopefully we're taking good care of the club. Cool. Thank you, volunteers. Constitution update. I know you all are on the edge of your seat wondering what's up with the Constitution. We're close. As you know, we published it this month for all of you to take a look at, read, maybe put yourself to sleep if you're having trouble sleeping. Yeah, how many have read it? Oofta! That's incredible. I don't have to read it. I was part of the writers. So that's great. And I say that's great because of the number of questions we got back. 2, 3 emails, a couple of clarification things. And I'm going to point to Dave. Dave, there's a microphone over here. I do want you, because otherwise it doesn't get on the recording, Dave. And they need it on the recording. So I know there's a couple things, and I'll just let you talk about them. Any questions?
Okay. A couple of things about the Constitution.
Oh, yeah, or stars, or your book.
Two. Anyway, so worked very diligently. So there was, obviously I kind of had a talk about this. Was it last
2 months ago?
2 months ago. 2 months ago. So some of you may or may not have seen it, but we had a committee that put together prior to the COVID, and did a lot of work. And then we had the COVID. It kind of ground to a stall for about a year and a half or so. And then we picked it up, and there are some notes and things. We got it finished up. And then we had a couple of sessions with lawyer. We have a nonprofit lawyer that we secured way back when. And so I think the Constitution at this point is much better now. So why do we have why do we get a new Constitution? Because there's one that was in the MAS, website that you can look at. But that one was created like in the 1980s. So a lot has changed since then. There's been a lot of new laws. There's also been a lot of changes with the MAS. And so it was time that we brought it up to the 21st century. And even though you don't have something in the Constitution that is statutory in nature, you're still responsible for it. So it's really best to have it in there so everybody can see, this is what we do. This is our makeup. This is our board, all that. So there's two parts to the Constitution, if you want to call it that. One are the Articles of Incorporation, which is the agreement between the MAS and the state and federal government. And it's much shorter because it's just basically showing how we're structured. Okay. And some rules about what do you call it? Conflicts of interest and things of that sort. And then the bylaws are the agreement between, the society and its members. Okay, that's longer because it goes to a lot more detail about our meetings, about our dues, about the board, terms on the board, things of that sort. Okay. By and large, it's not going to change how we do things. Okay. The main change is going to be in how the board operates. Some terms on boards are a little different. We still have an annual election that's half and half and all of that. So, but if you're interested, go ahead and read it and see what it's all about. The key here is that we have to ratify this new Constitution. And ratifying the Constitution has to go by the rules of the old Constitution to get it ratified, okay? Which requires 20% of the membership attend a meeting, and then the majority of that has to approve the Constitution. And Mark's gonna go into that in a little more detail, how we're planning on doing that, because we almost never have 20% in person. We've never had 20% in person, I don't think, maybe once. So that's what it's all about. Are there any questions about that?
Yeah, any questions in the room? Oh, cool. We should have voted this month.
Yeah, sure. Yeah.
When you were putting everything together, what really changed that stands out? Anything?
So the question is, when we did the Constitution, was there anything that really changed in the revision? A little bit about the board members and what their duties are, and the terms of each of the board members. Mainly, it was elaborating a lot more on how the MAS works. That's why there's a lot more in there. We went into some detail about some things that were, I would say, assumed before, and now we put that in the Constitution. For example, dues, right? We know that dues are set by the board, but that we've always had that the
Patron.
Yeah, patron dues were 2.5 times regular dues, and student dues are 1/2 that. I don't think that was in the Constitution before. It is now. Okay, so that's done constitutionally. So although the board sets what the standard membership dues are, then that determines what the patron and student dues are. So things of that sort.
And I think to further elaborate on some of that is the new bylaws really write down and give in a very detail of how we do business every day anyway. I mean, that we have board meetings and the board is responsible for handling the business of the club, and all of that is laid out in more details. And then it breaks down further about, what are we going to do with a member that is being mean or whatever, and not playing nice according to to what we would expect as other members. That has some definition. I mean, there's a lot more about the board, about how and how they're going to act and how they're going to carry out their responsibilities. You know, I think it's very detailed about how board members are elected and how long their terms are. Now, that was in the old Constitution, but now that is actually part of the bylaws, you know, rather than, I think if you think about the old Constitution as more acting like articles of incorporation. At least that's the way I was seeing it. And now it's, you know, now the articles of incorporation are the contract between the MAS and the state and the federal government, so that we can maintain our status as a charitable organization. And maybe if this all works, you know, eventually we'll get tax exempt status. Will save us some, you know, a little bit of money here and there on services and products that we buy. So that'll help. Not that we're needy, but, you know, why shouldn't we take advantage of stuff like that? And the articles of incorporation, I think that falls in line with the statutes and regulations set up by the federal and state government. And that's, you know, we really didn't even change that. I mean, that was a boilerplate that came
Very
from the
little change
library.
on that. Yeah.
Just because we couldn't change it. We're kind of bound. If we're going to be this, we have to fall within these rules. And so, I mean, the bylaws, I mean, they're what you want. It's the way we've been operating. So if there's something that somebody within the membership wants to change, you know, now's the time to raise your hand and say, hey, I don't like the way that's done. But in order to be a nonprofit with tax exempt status, there is another line that's in the sand that we can't cross that. We have to be careful what we change because we're expected to act a certain way according to the regulations. So we got it pretty close, you know, as to how we want to do business. The lawyer polished it to make sure we stay within the rules. And I think that's what you see.
Right. Yes.
Dave and Mark, may I interrupt? This is Bill Glass.
Bill Glass, you have the floor.
One, I wanted to back up to a comment that Dave made earlier that was incorrect. The old Constitution did specify the patron membership dues because it had the 2.5 times the regular dues in there. And for student membership, it did not specify a 1/2 rate. It just said a student membership would pay a reduced rate and left us to determine each year what that reduced rate would be. And there were a bunch of comments that Mark was just making about not-for-profit status. That got a little confusing because MAS has been not-for-profit for a long time and had our 501c3 status. So for example, donations to MAS were tax deductible, and we had all the benefits of being a charity and an educational institution. But the one problem was we did have to pay state sales tax because we were also classified as a scientific institution. And in Minnesota, scientific institutions are not exempt from state sales tax. So we did have the problem that MAS was having to pay tax on things that we purchased at times. But as far as being not-for-profit for donations to us, we were in great shape there because people could always take a tax write-off on donations they were making to us.
That's correct.
Bill.
Yeah, that's correct. And we were always 501c3. This, what I think the bylaws and kind of and the articles of incorporation just kind of spell it out with more detail now.
Yes.
And one of the things about the bylaws that we did change is that we made it says it's for, I want to say, charitable, educational, religious, and scientific. That's what we had before. Now it says or scientific. Okay. Now, what the lawyer told us is that this has been a problem, not just for the MAS, but for other organizations as well. And they've had difficulty getting the sales tax but the problem is that statement is statutory. I mean, it has to be in there, just the way it's written. So it's kind of a catch-22. But the Nonprofit Association of Minnesota, or whatever that's called, has been lobbying the state legislature to eliminate that state sales tax for any
Sure.
501c3. So
I think it's
an
important.
ongoing battle. That's, yeah.
Yeah, it's important to note that the only problem we're really having is with the state sales tax, which
Yeah.
is a pretty minor thing in terms
Right.
of the entire MAS budget and such.
Right, right.
And something else I wanted to comment on as far as changes that have been made in the new bylaws. The new bylaws are much more explicit on the duties of the various officers of the corporation. I mean, for example, in the past, it just said that MAS had a treasurer, MAS had a secretary, and didn't elaborate on what the treasurer or secretary had to do. Now there's close to a page of information on each of the offices as to what their duties are. And some of them are legal obligations to keep the state and the federal government happy in terms of, what documents have to be filed, what financial records have to be kept, audits performed, all sorts of things like that. So that's one reason the new bylaws are much longer, because it's providing a lot more detail on what the officers and board members have to do.
Right. Yep.
Are there any other questions
Yes, sir.
online? Yes, sir.
In Article 4 of the article, it states that we shall not attempt to influence any legislation.
Correct.
We can't. We're not big enough. We don't have enough money.
Right.
Seriously.
Does that mean we have to muzzle ourselves as an organization on any dark sky programs?
No, because it also says that we're an educational institution. So we can educate people without having necessarily influence legislature, right? So
We're educating the legislature. Is that what we're trying to say here? That seems very disingenuous.
why is that?
If we're lobbying, but we're calling it education.
But we don't actively go out and lobby legislature. We,
No, but what if they want to hear from us
um,
on a dark sky proposition?
then we'll educate them on it.
Yeah, we're not going to lobby.
That's not, if they're asking us, I wouldn't consider that lobbying if they're asking us.
The part of that paragraph that I looked at too is it says a significant.
Substantial.
Yeah,
You're right.
substantial.
You're right.
And so if a legislature comes up to us and asks us one time in the past 30 years, I don't consider that. Now, if we're out campaigning and holding signs, street corners, yes. We do have to be careful, we have to be aware of it.
Yeah.
Although I will say the difference between influencing legislation and not, and the regulation, has to do with the amount of paperwork that the organization must file with the Treasury Department. And with the assets just shown up there, I think we might have to do that anyway.
We already do that.
Well, then this might
Well-
not be any impediment to us at all.
It's not. I don't see where that holds us back. Not at all,
Then why is it in there?
because it has to be legally.
It's not if we're already submitting the paperwork.
Well, I got news for you. Let's not confuse reason with requirements here. Okay, so statutory, we have to have certain phrasing in the articles of incorporation and the bylaws. And we've talked on several occasions with a lawyer about that. Why is this in here? We don't do that or that type of thing there. And most of the time it's because it has to be in there to make it a legal document.
So, I mean, we contribute to the IDA every year. But in the grand scheme of their budget,
Yeah,
it's not, it's less than 1/10%.
it's $200.
Yeah, $200. They operate at over $1 million a year.
Yeah.
Their operating budget. And that's online if you care to go look. Because
And-
and they're also a
I was gonna
501(c)(3)
say,
also.
and oh, by the way, they're a 501c3 too. So.
Go to the Republican Party.
I totally agree with you. Any other questions? Did we answer your
Yeah,
question?
You had a question.
I'm involved in a number of nonprofits, and I'm interested in your reduction of the quorum, 20 to 10%. We, in some of the ones that I'm involved with, we've struggled with that. We were 35%, 40%, and the concern was that if it gets too low, then some radical wing of this organization come and make policy. And I'm just wondering what drove you to drop it from 20, 10
So the main driver on that is because historically we know about how many people generally attend meetings, even business meetings. Okay. And that getting 20% with the size that the MAS now is difficult. Okay. And that's probably safe there. So we talked at length about this with the lawyer and said, what is reasonable here? How low can we go and still be reasonable about this? And she has done this for a number of nonprofit organizations. She says, well, you can probably go as low as 10%. And I said, okay, well, 10% is a lot easier to get to than 20%. So
Because another way that some organizations handle that is to have different classes of membership, people that just send dues in every year and they've never been here for 10 years. They're maybe not as involved. So you define membership here as anybody who sends their dues in.
yes, that's correct. A member in good standing. So they paid their dues and they're still active, right? So that's,
Sometimes that involves definitions of some kind of activity or something besides just sending dues. That's what your attorney suggests. It just seems like a low number.
it
is.
is.
It is, and I agree with you. But if you, like when we announced that we're having a budget meeting in February, well, I would say that we would have a hard time making 10% at some of those meetings because there isn't a program that night typically, so, to get 65 people in a room at that point, it would be difficult. And the new bylaws actually would require us recording. So we may get 65 people or maybe have gotten 65 people in a room, but maybe only 60 of those people probably were members because we have a lot of members that attend online. There are a lot of people that attend online that are not members, so our business meetings now are going to be handled a lot differently, and I'm worried working into my next slide that we're going to record who comes in the door as to whether or not you're a member or not. We're going to record on the Zoom meeting that person is a member. We're going to be able to go cross-check that. We're going to see how they voted and things like that, so that we make sure that we're going to meet that 20% quorum before we change this constitution.
And just so people know, we've talked about this with the lawyer, so that everything we're doing is above board. She says it's the way we're doing it is fine. It'll pass muster. Okay, I can give you that. Okay. Any other questions?
Anyone else? Anyone else online?
Hey, Mark, this is Conrad. I didn't hear a thing from that, whoever was speaking.
Oh, okay. Well, we were talking about, I'll let Dave.
So what he was talking about was that in the new bylaws, a quorum is 10% of the membership, and he thought that was a pretty low percentage. That he's been a member of other nonprofit organizations, and they have in their bylaws like 35 or 40%, and they struggled to get that many people into a meeting to be able to have a vote. And we agreed, yes, that is a very low percentage, but it's something that we have talked to with the lawyer on, and she's a lawyer for a number of nonprofit organizations that have done a number of these documents, and so she says 10% is an acceptable amount for an organization. So if she says it, I'm okay with it.
Yeah, and even to go on about that is the fact that our next budget meeting will be considered to be a business meeting, and we'll be required to do the same things about recording members. It's kind of one of those things that if you go back, and ask what were we not following from the old Constitution, that would be one. Our business meetings, as long as I've been a member, there's never been that many members at a budget meeting. So, somebody could be a pain and say, well, none of that stuff was valid. And that would kind of be, I don't know how we'd handle that. We'd probably have to get a lawyer. Any other questions? And let's see. I guess we have a couple changes to make that are just typographical things. But as soon as we run those past the lawyer, we'll publish the new revisions online again, send out another email, and then that'll give you a chance to review those before the next meeting. And then at the next meeting is our plan to try and ratify this. And with the way it stands today, at 660 members, we need 132 members to be present at the meeting. It's a simple majority to ratify. So here in this room, we're going to pass a ballot. Here at this room, we're going to have a secretary and maybe, I hope, the membership coordinator in person so that we can record people coming in the door, verifying. Online, we're going to, that's actually a slide for me for later, but let me see how this goes. Yeah, so if we don't have a quorum, we're going to do this in July. And just as some incentive, the board is working on some prizes. It seems like, from what I know about amateur astronomers, is if you give something away of some value, and we're working on that we should get people to show up. And I'm not talking about $20 gift certificates. I'm working on a couple bigger things. And not a telescope. I mean, even things that you'd be able to use outside of astronomy. At least that's where I'm working. And maybe the board has some ideas. They've been tasked to think about that also. So yeah, I'm coming up on that, Dave. So next meeting will be here again. Same as today for all those that you showed up. If you want to have a mask, you can have a mask. We'll record it again. It's going to be on Zoom and posted to YouTube. So here, next meeting, speaking of that, so the way I'm going to set that up, and I had a long conversation with the people at Zoom and told them what my problem was. And they said, well, that's no problem at all. We'll just have, so what's going to happen is we're going to email out instructions about how to register. So the meeting will be set up that will require you that if you're going to attend on Zoom, you'll have to register to attend the meeting. And by registering, then we get your full name and your email address. Your full name and email address will allow us to cross that over with the membership list. And then we'll be able to validate you as a Zoom participant. We discussed this in detail with the lawyer and asked her if that's okay, because if you read the old Constitution, it doesn't really disallow it and it doesn't really allow it. So we're going with the fact that she told us if you document your process and your procedure as to how you're going to accept the Zoom members, then you should be okay legally. So that's what we're doing. So I'm telling you right now, watch your email for two things: the new updated articles of incorporation and the bylaws, and then instructions for Zoom. Dave.
That's how you validate. That's how they're going to know it.
Oh, thanks, Dave. That was on my previous slide. So on Zoom, there's a tool that we can use to vote. So it'll be a yes or a no. And that'll work. Yes, sir.
When you send out the revised constitution, will it be in a way that you can see the revisions? I mean, like a red one copy?
Maybe it will. Yeah, it's not that big of changes, but yes, whether we highlight them or redline them or however we do that, we can do that. Right, Dave? You're the keeper of the words. Just for that. Today? Nope. Today. Today, the new today, and what it's going to be. There aren't that many changes. If there's 30 words that are going to change, that's a lot. There's not that many. You're going to have to search to find them, I think. Any other questions? All right, moving on along. Slack tool is still there. It works quite well. I use it a lot. Consider signing up. Send an email to slack@mnastro.org if you're interested in signing up. There's lots of channels there. observing announcements is there, which any announcement that's posted on the MAS forum. I've also noticed that there's when there's a message posted on the observing forum, that translates over to Slack automatically. When we send out a MailChimp email, that also, so it's going to be hard for you to miss that email because it's in a couple different places. And then, so you can find it. MAS is on YouTube. At the recommendation of some hecklers from last month, I updated the link. So now it's a tiny URL. And all you need to have is that 3XWUM427. That's a lot shorter than the last one. Check us out. We're up to 145 subscribers now. And, I think monthly meetings get about 40 or 50 views in between meetings. So only thing is that those views would not count toward our quorum. So you gotta be live, so to speak, kind of. Anton and the Loaner Scope program. Oh. Thanks, John.
As always, members are welcome to borrow one of our 17 observing instruments. We have Dobbs, we have Smith-Cassegrains, we have a pair of binoculars, we have a solar scope, we have refractors, and you can check these out. And also we have a number of great courses on DVD. You'll find the whole list of our instruments and these courses on the website under members, Loaner Scopes. You just look down the list, make your selection, and that will send an email to me. Once I get that, I will contact you back via your email address. And generally we arrange a meeting in my driveway. And there you will check out the telescope. You'll sign a piece of paper where you'll promise to take care of it and return it after a month. And then it's yours to use. So new members back there, that is a really popular program. If you don't have a telescope or want to try a different kind of telescope, we've got them. And you, as a member, you are welcome to use them for a month. Any questions about our program? Yes.
What part of town are you in?
I live in Vadnais Heights.
Oh, okay.
Yeah, I live in Vadnais Heights. And actually, I started doing it this way when the pandemic started because we weren't meeting. So I started just opening my driveway essentially. And it turned out that worked really well because I'm retired, I'm home a lot, and I'm able to offer a lot of flexibility on dates and times to come pick up telescopes, return telescopes. And actually, I haven't had anybody have any problem with that. I've had people come from Mankato, from St. Cloud, to come borrow telescopes. Anything else?
Very cool.
Yeah.
Thank you.
Mhm.
When I was a newbie, I loaned 2 or 3 telescopes before I bought my first. So I think it's a great program, and it was small then. I think we only had 6 or 8, maybe less than 10, maybe 10. Then now we have what? 17. Oof. Plus all these DVDs. Website demo, Vaults. If you're on, the floor is yours, and I'm going to stop sharing.
I am here. Can everyone hear me?
Yes.
All right, let me share my screen. Can people see the website?
Yes.
Excellent. So as Mark alluded to, there's been a lot of activity on the new website. We've been working on this thing for close to a year. And what I want to do is make an announcement. We've decided we are far enough along on the development of the website. It's not 100% perfect, but it's very pretty much ready to go. So our plan at this point in time is to switch over the DNS and the domain pointers to the new website on the new server. And everything, so mnastro.org will, instead of going to the regular website that we've been used to for the last several years, to the brand new website that you see in front of you right here. So it'll be, I plan on doing this probably this weekend, most likely on Sunday. Also, the new website, new.mnastro.org, that address is going to go away. So the regular address will point to this one, and we'll have some kind of archive address for the old website for now. And then we'll kind of clean it up and archive it and kind of put it in storage. So as the new website is currently available at new.mnastro.org. If you have not already given a test run, you could certainly do it. Everything's working. Everything is up on that address. On the forums, in the announcement section, there is an announcement on the top that specifically also has that address. And it's a place for people to put in feedback, comments, errors that they might find, all that kind of stuff. So I'll keep that thread open on the announcements on the forum. The forum is not changing at all. That the forum address is staying as it is, and we're not touching the forum whatsoever. But what I wanted to do tonight is kind of give you for the people who haven't given it a test drive, a quick overview of it, and here it is. So this is the homepage, and this is where we get it. What we really try to do is entice and make it user friendly for beginners. How to become a member, what are resources they have for astronomy. We try to make it responsive with a modern interface and very, very mobile friendly. So you've got on the top bar, the basic menu and search tool and all of that stuff. So in the homepage here, I'm just scrolling around, like we'll have a member announcement, like this is an announcement about the Constitution files that have been shared. We'll put the updated ones up here as soon as that comes out. Below that is the automatically updated calendar. So this is we're using a new calendar tool versus the old website. It's called the events calendar, and it's one of the most popular website calendars for WordPress that's available right now. So automatically on the homepage, you'll see the upcoming 4 or 5 events for the public that are coming up. And if you want, you can dive into the full calendar by clicking in there and going into that. You can go into whatever kind of view. You can go into month view, list view, summary view, whatever you want. All of those are hyperlink available. So if we want to find out about the BSIG session that's been moved to Friday, here, click on that. And that information comes up here, and everything is good to go. So pretty much all the stuff that Suresh is doing gets transferred over to here as well. So that's that. Another very nice thing about this calendar tool is you can subscribe to this calendar, and you can either subscribe to it through Google Calendar, iCalendar, or export the ICS file. So if you're familiar with integrating online calendars, it's fully integrated with all of that tools. So this is the full calendar. It also filters it out by facility and like ELO events or Cherry Grove events or LLCC events, whatever kind of things you want. And so it's a very powerful tool. Everything is a live hyperlink and fully integrated into the site.
Hey, Vols, just a real quick question to Suresh. How do we get edit access to change events on this calendar?
Okay, that's something that I will do. We will gladly give the site coordinators edit access for the calendar. So as soon as we go live, we'll do training sessions and do it. It's actually quite easy to update and easy to add events, change events, move events around if something gets canceled from Saturday to Friday or Friday to Saturday or whatever. So
awesome.
It's something that we want to do. We want to enable all the site coordinators to be able to have access to those events and edit those pages as they see fit. And the tools that we use it's a Divi theme on top of a WordPress plugin. So it's really very easy to use, intuitive, and we'll make sure that everything, you can't go in there and screw something up in the nuts and bolts of the website, but we will give you access to the calendar to add events and change events.
Is there a push notification capability so that if somebody updates an event, the people that subscribe to that channel would get an alert or something?
It is. So if you've subscribed to the calendar, I haven't tried it myself, but it should be, especially if you're doing the iCal or the Google, it should automatically update a calendar that's been linked.
Awesome.
All right. So again, it's very responsive website. It's a modern look and feel. Everything's pretty clean. We're featuring all the new things that we're putting on there. Slack, as you can see here, our YouTube channel is prominently displayed, and there's a lot of things specifically for beginners. So up here in beginners resources. So basically, find out more about the beginner special interest group. It'll contact there or request an outreach event. So here, upcoming public events. So these are the BSIG events and the ELO events. So the various public star parties. Here's a good way to how to subscribe to the YouTube channel, how to read the Gemini newsletters, how to sign up for the MailChimp announcements, how to sign up for a BSIG event if you want to attend the BSIG events, all of that stuff. And a lot of background resources, links to online tools, all kinds of great things.
Looks great. Thanks, Phelps.
All right, so public star parties. This is really just a giant calendar tool that's specifically focused on most of the ELO public star parties. Outreach. So what we want to do is have a good ability, and this is basically a tool that contacts the outreach coordinator for a special outreach session. That's also in the beginners. Now in the about section, this is really this description of what we do it. This is the old Constitution. As soon as we ratify the new Constitution, this is going to get revamped, redone with the rules and everything that's links to the discussion forums, links to the various special interest groups. All right, board and contacts. If you want to contact any one of the board members, these are the board members and the site coordinators that they're all about us. You just choose who you want to contact, fill out the form, hit submit, and that person will get notified. All right, partnerships. So we've got a lot of partner organizations. Top on the list is the Astronomical League. Bellwin Conservancy with their brand new logo that just came out this week. Long Lake Conservation Center, Baylor Park. There's hyperlinks everywhere. You go to any one of those. Como Planetarium, all of that stuff. All those good partner organizations. We can go, there's a link directly to the Cafe Press store, just like the old website had. Link to our privacy policy. Membership, now this is a big one. So this is all the member stuff. So if you want to find a forum, find a discussion forum. If you want to look at star parties, these are our publicly held events. The beginners events. How do I join? How do I renew? So there's hyperlinks everywhere to go. Join or renew membership online. We've got new tools that are linked to PayPal. 1 or 2 year membership, either student, regular, or patron, based on our new rates. Optional donation with a full PayPal checkout. Really smooth, and it seems to work pretty well. Also, if you want to just do it paper the old-fashioned way, you can download the membership paper and send it in to Steve and the PO box. All right, that's membership. You can update your membership information. Key holders. Now, there's still some work to do on the key holder pages here, but it's basically information about becoming key holders for at the various locations. All right. Loaner Scope program. So as Anton mentioned, this website also has the same, basically the same loaner scope requests. So this one's active actually, so you can fill it out. And this one also gets to Anton. You can see a picture of each one of the scopes, including the brand new pair of binoculars that were donated to us a month or two ago. So that's how to get the loaner scope. Forums, again, you can enter the mass forum or just describe what it is. Weather. So all of our sites, we've got a very detailed weather page for all of our observing sites. So Astrospheric, Clear Sky Clock, Meteo Blue, everything. National Weather Service for all of the sites. Clear Outside, same thing. All of the sites ready to go. Moon phase, aurora, everything is there. Now, one of the things that's really cool about this, the new website, is its ability to work with mobile. So let me switch to what this website looks like in mobile mode. So this thing, it's just slick as can be on mobile. Everything works. Everything works really well there. So let's go start from the home page again. So we'll go into membership. Everything is there. It's all there on. It works great on mobile. Clean interface, fast loading. All right. Then lastly, we've got just like on the old website, we've got or is it down here? Facilities. So all of the facilities. We've got pages for each one of the observing sites. Very clean, tells you what all the equipment available, the observatories. We're still working on that, trying to clean it up. Links to the Slack channels on that, the key events, and also the upcoming events that's live at each of the facilities that's upcoming in the following year. So all of that's there, ready to go on mobile, and it's really nice and clean. Now, one thing that's really cool. So the search tool works as well, so you can search for anything on the website. One thing I do want to show you that's really good is the Gemini. So what we have is, where's the Gemini? About Gemini newsletter. Now, this is something I'm going to switch back to take it out of mobile mode. Makes it a little simpler to navigate here. All right. So the Gemini, the current issue will always be placed here for download, for viewing. But the nice thing about this new Gemini archive is it is every single folder here by year is available. Just like the old one was, but even the old scanned in documents, like the initial ones back in the Twin City Astronomy Club, all of those have been turned into searchable, readable, text-based archives. So I can come here and search any search term, and it'll extract out every Gemini for that search term. So let's search for Tinsley. I don't know if that's actually going to find anything. Nope, didn't find anything. So let's whatever. But this will give you it digs deep into every one of the PDF files. The other nice thing is for the board and for Father Brown, whenever we have a new Gemini, all we have to do is dump that PDF file into our Google folder, and this automatically gets updated. We don't have to do anything to change this page or do any website editing after this. So it's a really great tool for that. How to submit an article. If you want to submit something to Father Brown, right there, little history, all of that stuff is ready to go. So again, the plan is to switch over to from the domain server this weekend, but everything that's on the old website should be on here. There could still be some hiccups, but please feedback the information onto the forum, onto the announcement It's the announcement posting that's up there. So if there's any broken links or anything doesn't work or something looks funny, we'll get that fixed. One of the things that it doesn't have, we don't have a reservation system for equipment at the observatories, especially ELO, but that's something that we're talking about and trying to figure out how to best implement. But right now, the forums are where all that's happening. But I just wanted to give you a taste of the website. And again, it's working great on mobile, and everything is pretty much ready to go. Any questions?
No, this is completely new. We started this, well, the nerdery kind of dropped off and we were maintaining it ourselves. And then we found a need that we needed to update it again, just because it was not secure. So now it's a HTTPS website. And
Right. I
everything
didn't
is
mention
secure
it.
now.
Yep, it's full secure website with certificates, and that we will be moving ultimately the forum over to a different secure server as well. But right now we're just leaving it as is.
Any other questions? Baltz, I want to thank you. I saw quite a few chats that said thank you. Big round of applause in here. Yeah, I mean, Baltz, it's gonna be great, and use it and abuse it, especially in the next couple of weeks, couple of months, so we can make it better. And let's see where we can get it. Let's see, here we go. I'll be back in a second. All right, thank you, Baltz. Thank you very much for that demo. That's gonna be, life's gonna be easier for everybody that's got to maintain that thing. So what's next? I don't know, get the slide changed. I'm not going to talk about this too much because in the interest of time, I need to move along. But there's a few events, namely the lunar eclipse on May 15th. There's a star party at ELO. BSIG has got something going on. The beauty of this lunar eclipse is it actually starts at a reasonable time. You actually will see total eclipse before you have to get up to go to work the next morning. I don't know. Before you should be in bed. There are a bunch of star parties going on. The biggest one, as far as I'm concerned, is Astronomy Day at Eagle Lake on Saturday. Merle's in the house. Merle, do you need any help? Yeah. Merle says he needs help. So go to the forum, and I know he made a post on there looking for help. Volunteer. There's an opportunity right there to just manage traffic. There's a work party I know at the start to knock out some cobwebs from the winter, and just kind of get the place tidy before our guests get there. And that's definitely a way for you to help out. And your attendance there as a member would be recorded, and you don't necessarily have to be a key holder. I believe there will be plenty of key holders to run the equipment. The cool part is that there's other help that is always needed. Merle, did you get the LX200 installed? LX200 is installed. We got it back from California, or actually from Mexico, and I guess it's ready to go. So I don't know, is that going to cause us to have clouds now? So, and then there is the BSIG is having also a lunar eclipse party at Metcalf Field.
The BSIG, by the way, is tomorrow, not the 7th. We moved it to
I
tomorrow
understand
because of
that.
the clouds on Saturday.
Sorry, Suresh, I did not see your post on that. COVID, we already talked about that. Wear a mask here if you please. Wear a mask at observatories if you wish. There's not required. The MAS doesn't require it. Most importantly, though, I think if you're sick, stay home, please. Or if you've been exposed to somebody. So, as I said, as Suresh said, tomorrow night's the BSIG because that's the clear night of the 2 nights, or the better night of the 2 nights. And then May 15th, they are observing the lunar eclipse. Weather permitting, yeah, that's right. Yes, got it. Lunar eclipse is canceled at ELO if it's cloudy. Call for Gemini articles. Well, Volt's kind of hit it on already. If you guys have an article, something you want to write, something you've done, something you've experienced, trip you've taken, something you've observed, some equipment, something. Write an article, submit it to Father Brown. You'll figure out how to get it in there. Better know a constellation canceled for this month. Jerry Jones, front and center. John.
Good evening, everyone.
John, you got a mic?
I have the
Hang
pleasure
on.
of presenting
Mr. Microphone.
3
Speak to the microphone.
awards. Thanks, John. Good evening, everyone. I have the pleasure of presenting 3 awards this evening. And we'll make this quasi-snappy, but I do want to give people a chance to share a little bit about their progress. So, Claire, are you around? There she is, Claire Weaverling. Applause, applause. And so you have earned, we're always backwards when I look. There we go. Come on, fingers, you can do this. Thank you. You have earned the Globular Cluster Award. Congratulations.
Thank you.
Can you share a little bit about your experience?
Yeah, it was super fun. I did it over a summer. So started in like May and finished in August. I had to do 50 globulars. I described them, sketched them, but also classify them like on a scale of 1 to 12, how dense or how loose they are. So that was super fun and interesting.
Awesome.
Yeah.
Well done. Congratulations.
you.
Thank you. Kevin Carr is next. Come on up, Kevin. There he is. Kevin has received the Hydrogen Alpha Award. Here you are, sir. Congratulations. And would you share just a little bit about the difference between the Hydrogen Alpha Award and the Sunspotter Award?
Well, it's your sunspotter, you're observing the sun in white light with a solar filter. And in the hydrogen alpha, you're using a very dedicated telescope with hydrogen alpha filtering and very, very narrow band, which enables you to see prominences and other disk features that you otherwise wouldn't be able to see. Sunspotters primarily sunspots and a few other details, or this one is prominences, flares, and the like.
And do we have a hydrogen alpha telescope in our loaner program?
In fact, we do.
In fact, we do. So if you happen to be wanting to do the hydrogen alpha and you don't have an hydrogen alpha scope, get a hold of Anton and you can grab ours. Congratulations.
It took 4.5 years. to do this, but it only needs to be about 2 months at the most if you stick with it, because you have to observe the sun's disk for a period of 2 rotations. And then there's a whole bunch of other things to observe too in the meantime.
And boy, did we have a long solar minimum. Oh, man alive. So it's back. So those of you who want to do the hydrogen alpha and the sunspotters, now's the time before there gets too many and then it's too much work. And last but not least, Dave Tosteson. Come on up, Dave. Again, he was here last year. And Dave has finished the Stellar Evolution Award, which if you'd give a couple of notes about what the Stellar Evolution Award is like and what it means.
It's 100 objects. There are various things about stars, including supernova remnants, and the Veil Nebula and the Crab Nebula, of course, has the pulsar in it. You don't have to see the pulsar, just the nebula, but stars in various stages of evolution. And one of the interesting things is how far south it goes. -32 for M6 is the farthest south, so you need a good southern horizon. I did it all from my home. One of the most interesting one was VY Canis Majoris, which is one of the largest, if not the largest star known. It doesn't look like much, and it's very far south, but it's interesting when you see it to know what it is.
Yep, absolutely. Well, congratulations.
Thank you.
Well done, sir. And that's it. And as I always say afterwards, get out there and observe.
Thank you, Jerry. So next month, Professor Larry Rudnick is here from the Minnesota Institute of Astrophysics. A square kilometer of collecting area, early SKA Pathfinder results. Next month. This month, we are blessed to have Chuck Allen from the Astronomical League. He's gracing us with our presence again to make up for his storm out that he had in what was that, February, I think, or was that?
I think so.
It's February, yeah. So Chuck, you're going to do a talk on cosmic horizon. So I stopped sharing so you can share, and I'll be quiet now. Welcome, Chuck.
Thank you. Let me do something here. Okay, first of all, I want to thank you for inviting me back. Murphy seemed to have me and the MAS in its sights. I had the power outage because of the ice storm, and then I had the JWST program, which was lost because of a computer crash that occurred at the worst conceivable time that it could have. I was trying to get a galley back to a publisher. I had to get award nominees out on 10 award programs and get our bylaws revision project out to council. So I lost the JWST program. It was backed up to everything to within 2 weeks of that. So I appreciate you letting me change the topic this time. I would like to just mention a couple things. We are undergoing a bylaws revision as well. And it will not really change how we do business, but it fills in a lot of gaps. Our bylaws are very badly outdated. There are a lot of minor flaws with them, illogical sequences, misnumbered paragraphs, references to deleted sections, things of that kind. But we're trying to correct some things that are just not correct. One is our election procedure, which has a major flaw in it that fortunately has never surfaced in 75 years, but nearly did in 2019. And we're correcting that to deal with situations where we have no candidate on a ballot, or where a candidate on a ballot might die and be unable to serve. So we're filling in contingencies of that kind. One major change that we'll be suggesting is to correct a bad voting imbalance. As it stands now, our individual members pay 8 times more dues than individual members do, and have about 20 times the voting power. And so we're trying to rectify that, which will give clubs like your own a lot more votes in our affairs and elections. So I want to also thank Jerry and your club members for their dedication to the observing programs. I have the privilege of coordinating 3 of them, and I know and see how frequently your members participate in them, and it's deeply appreciated. Our new website, which we're spending a fortune to upgrade, has been naturally delayed a couple of months, but it should be coming up pretty soon. It's a complete overhaul of the website, combining the store with it, a new look, everything. So bear with us on that. Okay, with that, I will share screen here and go to this topic. Okay. First of all, does everyone hear me okay?
Yes, I think we can hear you fine.
Okay,
and
good.
I can see your screen.
Excellent, thank you. Horizons, of course, are simply limits on how far we can see. And in the case of astronomy, there are really 3 different kinds of horizons that we need to think about. And they are physical horizons, optical horizons, and horizons that I would call cosmological horizons that are imposed by the speed of light in an expanding universe. And so we're going to look at each of these briefly. The first is physical horizons, and these are simply the limits on vision that we have depending on the size of the world we might be standing on and how far above that world we happen to be. And to define a horizon, a physical horizon on a world, it's simply where your line of sight intersects a perpendicular to the center of the world at a right angle, as you can see here. Here, the person's line of sight to the horizon intersects at a right angle, perpendicular to the center. So this distance right here would be the distance to this person's horizon. There are 2 factors that affect this. Number 1 is the size of the world. On the Earth, if you're standing on the beach with your eyes 6 feet above the water, which can be done if you're 5 feet tall by standing 1 foot above the water level, your horizon actually stretches out to 3.1 miles. Might seem further, but it's not. What this means is if there was someone standing on a platform at water level 6.2 miles away, that person would be completely invisible to you, except for perhaps a little refraction effect that might allow you to see a little bit of the top of his head or her head. On the moon, being a smaller world, if you were standing with your eyes 6 feet above the surface, your horizon would be only 1.5 miles. So that's how far away that line is you see in all of those lunar photographs taken by the Apollo missions. There's a kind of a little rule of thumb you can use to calculate this. But the second factor, and I'll get to that in a minute, but the second factor is not just the size of the world, but how high above the world you are. In the previous two examples, you were 6 feet above the surface. But if you go up on a tower, like a fire tower, to an altitude of, say, 100 feet, your horizon would be about 12 miles away. And if you were to go a little bit higher to, say, the top of the Burj Khalifa, 2,722 feet, your horizon on a clear day would be 64 miles away. At the top of Mount Everest, your horizon would be 264 miles away, except you would, of course, be able to see the tops of other mountains at a considerably greater distance. And you can calculate this, and I had one slide out of order. You can calculate this with a very simple formula. Just figure out how high your eyes are above the surface of the world in meters and multiply it by 13 and take the square root. And that gives you the distance to the horizon in kilometers with fair accuracy. That's, again, the square root of 13 times the height in meters above the surface. And the answer would be in kilometers. Now, one time I was sitting in my office on the 28th floor, and I was looking out the window at about 5-6 miles distance to where I lived. And I was wondering how rapidly the Earth dropped away. In other words, if I were standing on a steel plate that was perpendicular to the center of the Earth, aligned to the center of the Earth, how fast would the curvature of the Earth drop away underneath that steel plate? And the answer is at 1 mile, 8 inches. And at 5 miles, it was actually 17 feet below the level of the steel plate, which means that as you look out to a horizon, it's actually lower than it should be. If the Earth were flat, it would appear higher in the sky to you. At 10 miles, the drop is 67 feet. That's an easy distance to see from any location. It's roughly 8 inches per mile squared. And so you can keep that little factoid in the back of your mind if you're ever interested in figuring out just how much curvature there is. Now, it's generally said that you cannot see the curvature of the Earth unless you go above 35,000 feet and have a 60-degree unobstructed field of vision, which you rarely do out of a plane window. And while this is true, it is also true that you can detect the curvature of the Earth from the Earth's surface. One way to do it is to watch a ship sailing off in the distance, with perhaps while you're swimming, with your eyes just a few inches above the surface of the water. You would very clearly be able to detect at some point that the sails of the ship, or perhaps the top of the tanker, was visible, but the bottom or hull of the ship was no longer visible to you. At Lake Pontchartrain, there is a line of power lines that crosses the lake. It's a very shallow lake, of course, and it drops away over the horizon with a distinct curve, which if the Earth were flat, it would not have. In fact, if the Earth were flat, that horizon would be 288 feet higher at the horizon, and those lines that you see there would remain straight. They would not curve over the horizon. So this is definitely visible at Lake Pontchartrain. There's also a place where you can experiment with it. The Bonneville Salt Flats, of course, is an old lake that simply evaporated, leaving its salt deposit behind. And it's a very conformal surface to the curvature of the Earth. And so what you can do is place a flashlight that's perfectly horizontal to the ground. You have to be very careful about how you determine that. And then move away about 1 mile. And if you can drop your head below about 8 inches, that light will disappear because of the curvature of the Earth between you and the light. It is something that's been detected. I've also heard of people who have climbed up on phone poles along the Bonneville Salt Flats, along the highway that runs across there, and have actually detected that the rungs on the successive poles formed a sheet rather than blocking each other's view in the distance because of the curvature. The next kind of horizon we need to talk about are optical horizons, and these are limits on how far we can see that are imposed by human vision. And this comes in a number of varieties. But first of all, we need to talk about photons and just how many are emitted by certain things. So I'll give you an example. One is a 100-watt light bulb. A 100-watt light bulb puts out 300 quintillion photons each second. So there are a lot of photons emanating from light sources. Now, an experiment was done down at Texas A&M in Texas, where a candle was placed on a flat plane, and people got as far away from it as they could and still detect it. Now, this, of course, is subject to dust in the air, moisture in the air, and so forth, also interfering light, because it was not ever perfectly dark anywhere they happened to be. But they were able to detect the light at 1.6 miles. And the flux, that is the number of photons entering a fully dilated pupil, each second, was calculated at about 2,700 photons, roughly equal to a magnitude +6 star. However, if you could find yourself in a position, perhaps in the middle of the Pacific somewhere, where all extraneous light was eliminated, theoretically a magnitude +8.5 star would be visible to the naked eye. This is a flux of about 270 photons per second if you have a fully dilated, youthful pupil that opens to 7 millimeters. Now, I will point out that the human eye really records images, if you will, with an integration rate that is considerably shorter than a second, which means you're actually recording fewer than 270 photons if you see the star. We'll adopt about 1/5 of a second for that integration period. Now, I had an experience observing at Patoka Lake one time in Indiana, where I was after, I think this was back when I was doing the Versal 2 program a couple of years ago. And I was after NGC 499, which is seen here. And when I was observing it and sketching it, I noticed a little fuzzy object over on the right side of the field. I happen to have the guidebook with me, which I rarely take with me on these occasions since I've planned differently. But it said to look for NGC 496 in the same field. And so I saw it and began sketching it as well. And as I was jiggling the field back and forth to get a feel for these two things, I noticed some little ghostly thing that was moving along with the field in between them right here. I didn't have any way of looking it up at the time, but I went home, found this photograph, and lo and behold, there it was, NGC 498, which was listed at magnitude 16.0, which with a 12-inch telescope is quite remarkable under the circumstances. So I decided to calculate exactly how many photons I was seeing per integration rate of the human eye and brain working together. Now, a zero magnitude star casts about 500,000 photons each second on a square centimeter of the Earth's surface. If you can imagine how much light a zero magnitude star casts on the ground in 1 square centimeter, that's 500,000 photons. And it's not exactly the kind of light you'd be reading a newspaper in. A 12-inch SCT minus its obstruction, about 826 cubic centimeters. So that means I was getting about 413,000 photons per second. I had to divide by 2.5 million in order to get it down to 16th magnitude, which reduced it to 172 photons. I then accommodated glass transmission, extinction at 50 degrees, and then corneal transmission, and then the integration rate, about 1/5 of a second. And it came down to 18 photons per integration period, which is really quite remarkable. And it makes you wonder how few photons the human eye can actually detect. Enter Dr. Ali Pasha Veziri at Rockefeller University, who developed a fantastic device that was capable of emitting single photons to the human eye. The subjects were asked in a totally dark room, were asked to stare at a fixation light, a very faint red dot. And photons, single photons, were emitted into the eye during a period between 2 audible signals. Each time that occurred, they were asked to indicate whether they had detected a photon, any kind of flash during that period, and with what level of confidence they detected it. If they were not sure at all, they would say so. If they were fairly confident they had seen something, they would press a button to indicate that. What they found was that the forced responses that had low confidence indicated seeing the light 52% of the time. However, the forced responses where there was high confidence of seeing the light 60% of the time. And this was deemed to be statistically significant for the detection of single photons by the human eye. This research has been challenged by a couple of other researchers who think that the limit is more like 5 or 10 photons, but it's a very small number of photons either way that the human eye can detect. So what are some of the furthest things that we can see with the unaided eye? The furthest star you can see with the unaided eye is probably V762 Cassiopeia, magnitude plus 5.8, lies at 16,308 light years. There are obviously fainter stars you can see with the naked eye, but this is the furthest of those. Might give it a try some night. However, there have been stars in the past that were further. An 1885 supernova in Andromeda, shown at magnitude plus 5, and it, of course, was at a distance of 2.5 million light years. None of us were around then to see it. However, there was an event that occurred on March 19th, 2008. I don't know that anyone detected it visually, but they could have. This was a gamma ray burster in Pleiades, and it rose to magnitude 5.5 and stayed above magnitude 6 for about 30 seconds. Here's the light curve for it. This is 10 seconds, 100 seconds. So you can see it was a very short-lived peak, but it would have been visible. And had you seen it, you would have been seeing an object at a distance of 7.5 billion light years, had you been very lucky. And again, I don't know of anyone who detected it individually. This young man I met in 2019. He lives on a family farm in Evening Shade, Arkansas. His name is Scott Harrington. And Scott, I stumbled upon Scott when I was researching what the limits were on naked eye visibility of objects and also using binoculars. He had published online a document called 250 Deep Sky objects visible to the naked eye in 735 binoculars, a project he started when he was 14 years old. He's since advanced this project to incredible levels, including larger and larger instruments that he's acquired over the years. He now writes for Sky and Telescope magazine. He had the cover article in Sky and Telescope about a year ago, dealing with H2 regions and galaxies. So he's a consummate observer. And his indications helped me develop some research on what the limits of naked eye visibility would be as it relates to different kinds of objects. It appears the furthest emission nebula visible to the unaided eye would be the Swan Nebula at magnitude 7.5 at 5,900 light years. The brightest of the open clusters, NGC 884, one of the two components of the double cluster at nearly 10,000 light years. M2 and Aquarius at 37,500 light years would fill the bill for the globular clusters. And the furthest galaxy that we have found anyone detecting with the naked eye is M81 at magnitude plus 6.9, 11 million light years. With those 7 by 35 binoculars, you might be able to stretch to NGC 3607 in Leo. That would be as far as you could see with those, 69.4 million light years. With amateur telescopes, we can go even further. Many of you I know have observed 3C273 in Virgo. This is a quasar that's very well known, very popular with amateur astronomers, and it's probably the furthest thing that most amateurs have ever seen. Flies at about 2.4 billion light years in light travel time and shines at magnitude 12.9, very easily detected in small instruments. But since many amateurs have access now to Dobsonians, either with their club observatories or among their friends, or perhaps they own them themselves, with 18 and 20-inch Dobbs, something much further is detectable. By the way, this is how bright 3C273 would appear if it were at Arcturus's distance, 36 light years away. It's a really bright object, but nowhere near as bright as this next one. The next one is an object that is known as APM 0827952555. It's a quasar in lengths. It is gravitationally lensed, shines at magnitude 15.2, and it is this heavily reddened object that you see right here. This object is visible in large Dobbs, and it lies at a light travel distance of 12.05 billion light years, more than 12 billion light years in a universe that's only 13.8 billion years old. So you are literally seeing across most of the observable universe when you observe this. It's an extraordinary thing to try to detect. It's a little bit tricky to find, but you can work it out with some nice charts, and I can help you out with that if any of you are interested in doing so. Now, if you were to bring that object to within Arcturus's distance of 36 million light years, excuse me, pardon me, 36 light years, you would have a big problem. And squint just a little bit for this next slide. If you brought APM to Arcturus's distance at 36 light years, its magnitude would be minus 45, 16 million times brighter than the sun. An extraordinary object. Professional telescopes, of course, can reach a lot further. And the furthest confirmed object that we've ever imaged is this little protogalaxy in Ursa Major called GNZ11. The Z11 refers to the extent to which its light has been stretched 11-fold by the expansion of space that it's been passing through. And its light travel time to us is 13.4 billion years. So we're seeing this object as it was just 400 million years after the Big Bang, less than half a billion years after the Big Bang. Its current distance from us is 32 billion light years, and we're going to talk about that in just a minute. This is really what the galaxy looked like 13.4 billion years ago. It looks red to us now because, again, its light has been stretched. This little protogalaxy is just about 600 light years across, and by now it has merged and remerged to form probably a spiral galaxy that has since merged with other spirals to form perhaps an elliptical galaxy. We have no way of knowing. However, in April, just a few weeks ago, some astronomers in Japan detected something even further. However, spectroscopically, it has not been studied enough to confirm it as the new record holder for the furthest thing we've ever observed. It's called HD1 in the constellation Sextus. Its light travel distance, 13.5 billion light years. A Z factor, a stretching factor of its light of 13 times. And its current distance from us, 33.4 billion light years. But again, not confirmed. And what you're doing is asking, well, how far can we see? And the answer is not much further than this, clearly. Because if you try to look much further back in time, you're looking back into the dark age before stars began to form. So if anything beats HD1, it's going to be like breaking the world high jump record at 8 feet 1/2 inch. If somebody breaks it, they're going to break it by just a centimeter, not by any great margin. We might find a few things a little tiny bit further, but not likely. The JWST, of course, will be searching for just such things, and its gold mirror, which is highly sensitive to infrared light, will be studying these heavily reddened galaxies, that protogalaxies that were forming in the very early years of the universe's existence. Well, this brings us to the last topic, which is going to be a little mind exploding, and that is the cosmological horizons that are imposed on us by the fact that the universe is expanding, that it's accelerating in its expansion now, and that, of course, we're limited by the effects of the speed of light. And so the first thing we need to do is talk about some of the basics that have to be considered when you start talking about how far you can see cosmologically speaking. The first fact you have to bear in mind is that the universe is expanding. The rate has been studied by a number of satellites, Planck, WMAP, and COBE, and is thought to be between 67 and 74 kilometers per second per megaparsec. Now, I have people ask me all the time, well, how fast is the universe expanding? Is it expanding at the speed of light? And I say, well, yes and no. It depends on which 2 points you pick in the universe. It's like you have a group of kids surrounding a very stretchy rubber sheet that's 10 feet by 10 feet. And over on one side of this rubber sheet, you have a white dot, that'll be the Milky Way. And 1 inch in is a green dot, a green galaxy. And then on the far side of the 10-foot by 10-foot rubber sheet, a red galaxy. And you ask these kids to stretch the rubber sheet out to 20 feet by 20 feet in 1 minute's time. And then you ask the folks on the green galaxy and the red galaxy, based on your observations of the Milky Way, how fast was the universe expanding? And you'll get different answers. The folks on the green galaxy will say, well, we went from 1 inch to 2 inches in 1 minute, so it's 1 inch per minute. The people on the red galaxy will say, well, we went from 120 to 240, so it's 120 inches per minute. They seem to disagree. But if you ask them again in a different way, if you say, well, how fast did you observe the Milky Way distancing itself from you for each inch of separation that you started with? You'll get the same answer. They'll both agree that for each inch of separation that we started with, we experienced 1 inch of separation per inch of separation. And that's what you have to do when you talk about the rate the universe is expanding. The term we use is a megaparsec. It's a distance that's about 1.5 times the distance between the Milky Way and Andromeda. And for every megaparsec of space, you will have expansion occurring at a rate of about 48,000 miles per hour per million light years, 74 kilometers per second per megaparsec. That comports with a rate of about 48,000 miles per hour for every million light years. Does that mean Andromeda is moving away from us at 2.5 times 48,000 miles per hour, since it's 2.5 million light years away? Not at all. In fact, it's moving toward us. Gravity overcomes this Hubble flow. The expansion of the universe is retarded completely by the effects of gravity in galaxy clusters. It occurs mostly in the spaces between galaxy clusters. The second thing we have to consider is that if you get 2 points that are far enough apart in this expanding universe, namely 14.4 billion light years, those points will be separating at the speed of light. If you get 2 points that are, say, 28.8 billion light years apart, they will be separating at twice the speed of light. No, this does not violate special relativity at all. Nobody's observing anything moving away at or greater than the speed of light. Nothing is moving through space faster than the speed of light. The Earth, any galaxy you look out here, they're just sitting in space, but the space is expanding. The third thing to keep in mind is that the universe is not only expanding, but now is accelerating in its expansion. In the early days, it was expanding very fast, but then started to slow as matter began to exert its gravitational effect. But as matter became more attenuated in the larger and larger universe, dark energy took over, and now we have an increasing rate of expansion observed today. This is the result of studies of supernovae. And the final thing to consider is that the expansion of the universe and the speed of light make distances really hard to understand. And this is one of the key points I want to make tonight. If you look from Crater Lake, Oregon, down to Mount Shasta, you have a line of sight view of 114 miles. Now, if you were to pace that off somehow, you'd find that you had covered 114 miles. If you look at Google Earth and use a measure, it'll be 114 miles. If you use a satellite view, it'll be 114 miles, because that's its distance. And you're very comfortable saying that. You're very comfortable with what that means in terms of travel time. But when you're dealing with something like GNZ 11, that little galaxy I showed you a while ago, we have a big problem, because there are 3 distances that you can really apply to it that are all at the same time valid distances and at the same time problematic. For example, we can say that when the light that formed the image of GNZ11 that we have, which is seen here in this little box, left the galaxy was only about 0.8 of a billion light years away from us. But as the light began passing through this space, the space between the galaxy and the Earth was expanded. And so the light travel distance ended up being 13.4 billion light years. But during that time, the galaxy had developed and receded to a distance of 32 billion light years. All three are therefore valid. However, they're all problematic, aren't they? We know the galaxy can't be 0.8 billion light years away because the light took 13.4 billion years to get here. We also know that 13.4 billion light years doesn't work because if we could magically transport ourselves back up this light path, 13.4 billion light years in an instant, there'd be nothing there to see, no galaxy. And we know the galaxy actually is out at 32 billion light years right now, but how in the world can we see that in a universe that's only 13.8 billion years old? So these are the little problems we have with imagining how far something is when we're talking about these cosmological distances. Now, to explain this in a little better way, I'd like you to imagine that a father has taken his daughter to a local swimming pool to finish teaching her how to swim. He's taught young Emily to do the crawl and to kick her feet and to turn her head to breathe. And now it's time to let go of the wall and swim to dad. And the wall, that's going to be GNZ11. Emily's going to be our photon, and dad, that's us. We're the Milky Way. Now, the only problem is this is what we call a magic swimming pool. The swimming pool's sides get further apart constantly. The bottom of the pool stretches. Extra water is sprinkled in to keep the depth up. It constantly expands. And so Emily lets go of the wall and begins to swim to 10 feet to get to dad. And she swims and swims. And lo and behold, by the time she gets to dad, she's covered 100 feet. And worse, when she looks back over her shoulder, the wall is 300 feet behind her. This is GNZ11. It was 0.8 of a billion light years away, 10 feet away, when the light left there, when the light left GNZ11 to start its trip to us. By the time the light got to us, it had covered 13.4 billion light years. But by the time it got to us, the galaxy had receded to 32 billion light years distance. This is the effect that the expansion of the universe has on our conceptualization of distance. There's another problem. If Emily turned around and tried to swim back to the wall, she'd never reach it. That wall is now beyond her horizon. There's simply too much pool expanding, and she can't overcome the amount of water that's expanding ahead of her. It's beyond her horizon, which brings us to that final thrust of this program, which is to talk about the horizons that apply. Now, I'd like you to imagine that this light blue circle here is the range, 13.8 billion light years, from which light has had time in the 13.8-year age of the universe to reach us. Light has not had 15 billion years to get to us. It's had 13.8. Also, I've drawn this line here. This is that Hubble distance where things are being pulled away from us at the speed of light, 14.4 billion light years. Now, these are close together. That's merely coincidence. It could be otherwise. There's no link between the two. So this is the light travel distance of GNZ11. This isn't really where GNZ11 is. It's out here at 32 billion light years now. It was here about a billion light years away when the light left there. The light travel distance ended up being 13.4 billion light years, and the galaxy today is out at 32. Lots of other galaxies out there, about 250 billion or more of them, and they're all closer today than GNZ11 because GNZ11 is the furthest one we've ever observed. And the further out you go, the more galaxies you encounter, and there are billions of galaxies out here that are a little bit closer today than GNZ11. Now let's imagine hypothetically that when the universe became transparent shortly after the Big Bang, that there had been a galaxy already formed and shining, whose light took 13.8 billion years to reach us. Now that would be the furthest possible object whose light has had time to reach us. Nothing was shining that far back in time, but if it had been, it would have taken the full age of the universe to reach us. And if we saw that galaxy today, that hypothetical galaxy, we would know that today it was out at 46 billion light years. And that marks the cosmic particle horizon. 46 billion light years is called by professional astronomers the edge of the observable universe. 46 billion light years is the location today of the furthest possible things that we can see today. That happens to be GNZ 11 at the moment. But again, if there had been something shining whose light took the entire 13.8 billion years to reach us, we would know that it was out at 46 today. Now you can kind of pull your Etch-a-Sketch up and erase it now, because we've been talking about old light. But now let's think about new light. What if something happens on a galaxy at 15 billion light years? Let's imagine that right now, today, there's a galaxy at 15 billion light years. The question is, can we see it? Now you notice that it's separating from us at greater than the speed of light. It's beyond the Hubble distance. Can we see it? Sure. Sure we can. We can see all of these galaxies. We can see GNZ 11. We can see billions of other galaxies in our Hubble Deep Field. We see their old light they emitted when they were much closer. The same is true of this one. This galaxy was once closer to us, and its light is streaming in, and we can photograph it easily. But what if a supernova goes off in this galaxy today? Will we ever in the future be able to see it? Can the light leaving a point that is separating from us at greater than the speed of light ever reach us? Amazingly, it can, because while this galaxy and we are separating at greater than the speed of light, the distance between the galaxy and the Hubble distance is not. And so the photons can make it inside the Hubble distance into a region that is not separating from us at greater than the speed of light, and they will eventually make it to us at some point in the future. Obviously, the light hasn't had 15 billion years to reach us, and if the light leaves there today, it's going to take a great deal of time to reach us. Now, this is only true out to 16 billion light years. At 16 billion light years, an event occurring today, those photons will just barely be able to make it to our Hubble distance and eventually make it on in. Anything further away, those photons cannot make up for the expansion of space that's occurring and the accelerated rate of expansion. They will never make it inside our Hubble distance, and we will never see it. So 16 billion light years becomes another horizon. It's called the cosmic event horizon. It simply means that anything occurring today beyond that distance, we will never see. If you imagine that there is a galaxy where a supernova is occurring today at exactly 16 billion light years, when that light finally arrives here, we will know that that galaxy at that moment actually lies at 62 billion light years. And that's called the future visibility horizon. It's the location of the furthest things that we will ever see when we see them. So if a supernova goes off today at 16, we're going to have to wait a long time before those photons reach us, but they will be able to. And when they do, we'll know that that galaxy that hosted the supernova is today, when we see it rather, at 62 billion light years. So those are the horizons that apply. Now, important to understand about this cosmic event horizon is that everything beyond the cosmic event horizon is what we call unreachable. Now, you'll notice that that includes GNZ 11 and all of these billions and billions of galaxies that we see in our Hubble Deep Field. And in point of fact, 96.7% of galaxies that we can see now are already unreachable. We can't get a signal to them. They can't get a signal to us. The last photons that we'll ever see from those galaxies left those galaxies long ago. Anything occurring there now will not reach us. Anything occurring even recently will not reach us. Kind of daunting. It's also kind of daunting when you consider that these horizons are actually moving toward us. They're moving in very slowly, but as the universe accelerates, the distance from which light can reach us gets closer to us. And so these horizons would eventually move into the point where only the local group of galaxies would be visible since they're gravitationally bound. But that's far, far in the future. there's always the question then of, well, how much lies out there beyond it? We'll never see anything occurring today beyond 16 billion light years. And the limit of our vision is the edge of the observable universe, which is 46 billion light years. So what lies beyond? How much more is there than the part we can see within 46 billion light years? Well, we've been studying the cosmic microwave background, trying to, with the COBE, WMAP, and Planck satellites, trying to get a handle on whether we can detect curvature in the universe. It's a complicated process, but it's very effective. Unfortunately, the universe just proves to be flat with every measurement we make. And it indicates a flat universe with an error of 0.4%. But that sets a lower limit on the size, because if the universe is flat with an error that big, then the universe could be curved but undetectable if it's at least 250 times bigger in radius or 15 million times bigger in volume than the part we can see. Oxford University suggests that 15 million times larger than the volume of space out to 46 billion light years is as small as the rest of our universe can be. Alan Guth, who was the author of inflation theory to begin with, estimates it at 300 sextillion times larger. Andre Linde, a co-creator of inflation theory and chaotic inflation theory, estimates it at 10 to the 40,000th power times larger as a possibility. If you were typing that number on your computer in Times New Roman 12-point type, it would be a 1 followed by 2 miles of zeros. Very large indeed. So that's it. And I will stop sharing now. And if anyone has any questions at all, I'd be more than happy to entertain them. But I caution you, there is no such thing as a dumb question when it comes to these kinds of questions. They're very hard to get a grasp on quickly. It takes time. It took me a long time, a lot of conversations with an astrophysicist friend of mine at Princeton, a lot of reading. But if it stimulates your interest in the idea of horizons on how far we can see, hopefully it will have that effect. Thank you.
Thank you, Chuck. One question here in the room from Dave Tosteson.
Yeah, I'm just seeing an MAS symbol here. Should I be seeing something else or?
No, I think that
okay.
That should be good.
Sure.
Hi, Chuck. Thanks for your talk. I have a comment. I was in Chile a couple of years ago and saw Centaurus A naked eye, about 13 million light years.
Wow.
And I have a project to see quasars at various ongoing redshifts. And I've seen one at 5.3, which is about 12.5 billion light years, and possibly one a little over 20th magnitude with my 32-inch reflector that is at almost 6.0, which is 12.8.
Okay.
billion.
I'll make a note of that. I think
Thanks.
this was based on northern observing. Although Centaurus A is 5128 NGC, I think it is visible from the northern hemisphere. Thank you.
Any questions online? Go ahead and open your mic. I didn't see anything on the chat. Wow, quiet group there tonight.
This program has that effect, and don't feel bad about
Maybe
it.
they fell asleep. I mean, everybody's awake in this room. Maybe they're asleep online. Well, a question in-house.
I can't hear it.
Yes, Chuck, many years ago, I think I read that if you were on Venus and somehow the atmosphere was transparent enough, you could see all the way around the planet because the atmosphere is so dense and the refraction much greater than Earth's refraction. Do you have any comments on that?
Yeah, well, if it weren't so full of sulfuric acid and the clouds would prevent that. But if it were clear and you have that gradient in pressure, it's 90 atmospheres of pressure at the surface. So you're going from 0 at the top of the atmosphere down to 90 atmospheres at the surface, 90 Earth atmospheres at the surface. That kind of change in density creates tremendous refraction. You know, refraction occurs as light passes from a medium of one density to another. So that's extreme. So any place you would be on Venus, you would feel like you were at the bottom of a fishbowl. The horizon would be above you and you would be seeing far over it. Whether you'd see all around it, I can't speak to that. That would obviously require a totally clear atmosphere of some sort, and I don't know the answer to that. But yes, there would be extreme refraction occurring on the surface.
Yeah, thank you, Chuck.
One question online, Chuck, is Michael Copper's looking. He says, "Could I get your slides on cosmic distances for my astronomy class?"
Sure. Well, which when you say cosmic distances, what are you referring to?
Michael, if you're can unmute your mic. And
The reason I ask is I think I gave a distance ladder program one time to your club back a year ago. Are you referring to part of this program tonight?
the last section.
Oh, yes, absolutely.
Yeah, so I will, I'll forward you Michael's email address and you guys can
Absolutely.
talk it out. Anything else? Well, Chuck, thank you very much for your time tonight. Thank you for sharing.
Appreciate it. It's a really pleasure to be with you. You are one of our great clubs, and I really enjoyed listening to the first hour. It shows a lot of dedication by a lot of people, and it's something that I see through the observing programs and just generally throughout the league. So thanks for all you do, and keep up the great work.
Yeah, same from us to you. I hope your computer problems work themselves out.
It's the new computer. It's up and running. I have to say the gulf between Windows 8 and Windows 11 was a little larger than I expected, but I seem to have ferreted it out now. So,
well, good luck with the learning curve on that.
Okay, thanks.
Thank you, Chuck. Good night.
Okay, good night.
Everyone else, members, everybody online, thank you for joining tonight. And we'll see you next month. Recruit your members, your friends. We need a big meeting next month. We're probably about 50 short, I think, for this if we were going to ratify tonight. So bring your friends. Thank you.